Synthetic division is a shortcut method for doing long division with polynomials, but it only works when your divisor is a first-degree binomial. So in the denominator, or you must be dividing by something that looks like, x plus 2, x minus 7, x minus a half, x plus 0.38. It can also be imaginary numbers, so I can have x minus 2 plus I, or x plus 3 minus 4i, and we'll talk about those imaginaries last. But notice that these are all first degree, right? The first degree, these are all first degree binomials, okay? So let's look at an example. So if I want to divide the polynomial 5x cubed minus 6x squared minus 28x minus 2, all divided by x plus 2. The way that I set this up is first going to take the opposite of this guy. What makes this guy 0? So what makes this 0, what makes my denominator 0 is negative 2. So I'm going to put a negative 2 out here. And then I'm going to write all my leading coefficients, so 5, negative 6, negative 28, and negative 2. I also want to make sure that all of my terms are going in descending order, the order matters, and that there are no missing terms. So if this x squared term was missing, I would have to put a 0 here instead of this negative 6 if I didn't have this term here. We will look at an example like that. But just make sure that they're going in descending order, and you just simply write all their leading coefficients. So then what I want you to remember is multiply and add, because multiply and add is what you're going to repeat several times during this process, okay? So the first thing I'm going to do is I'm going to bring down this 5. So this 5, the first term, always just drops straight down. And now this is where I'm going to multiply and add. So what I'm going to do is I'm going to multiply these two, negative 2 times whatever number is here, and I'm going to put it here and then add straight down. So multiply, put it here, add. Then we're going to multiply, put it here, and add, okay? So this is what that looks like. So negative 2 times 5 is negative 10. Negative 6 plus negative 10 is negative 16, so I'm adding. Now I'm multiplying again for positive 32. I'm adding again for positive 4. I'm multiplying, negative 8, and I get negative 10. So this is my final answer. So let's look at how to interpret this guy. So the last term here is the remainder. So this is my remainder. So I have a negative 10 as a remainder. And you notice that that our problem started out with a cubic, okay? So we started out with a third degree equation, right? So if we have a third degree equation, once we do synthetic division one time, our answer is reduced by 1 degree. So if we start out with a third degree, we end up with a second degree equation. If this had started out with, say, a 7th degree, then this would be a 6th degree equation. You just reduce it by 1. So now I can rewrite my expression as 5x squared minus 16x plus 4. So notice that I took my third degree and I reduced it by 1, and then I just went down in descending order. My remainder, don't forget your remainder is negative 10 over x plus 2. Because remember, you always put it over that divisor just like we did last chapter. And that would be your final answer. Okay, so let's look at another example. So let's look at the example, if we have, negative 1 x to the 4th plus 3x squared minus 4x minus 5, all divided by x plus 3. Okay, so let's go ahead and set this guy up. So we're going to put a negative 3 out here, right? Remember, it's the opposite. It's what makes this guy 0, right? So negative 3 plus 3 is 0. And then my coefficients. So this is a 4th degree equation, so I see it's a 4th degree, and they go in descending order, but I hope you notice that there is something missing here, right? There is not an x cubed term here, right? So I'm going to put a 0x cubed term here, okay? So I'm going to write negative 1, 0, positive 3, negative 4, negative 5. So now I have all of my terms in descending order. So just like before, we bring this first guy down, so we get -1, and we're just going to multiply and add, multiply and add. So 3, -3 times -1 is +3, and I add straight down, 0 plus 3 is 3. These two multiplied is -9, -3 times +3 is -9. When I add straight down, I get -6. -3 times -6 is +18. +18 minus 4 is +14. -3 times +14 is -42. And when I add straight down, I get -47. So remember, we need to remember how to write this as our answer, right? Because this is not an answer form. This is not really what I'm looking for at this point. So really, my answer is -1 x to the third. Remember, you have to reduce it by 1 degree. So if this started out as a 4th degree, my answer is now a 3rd degree. Plus 3x squared minus 6x plus 14, and my remainder is -47 all over x plus 3. And that is my final answer. Okay? So now you know how to add zeros in there. So let's look at one with imaginary numbers. So if we have imaginary numbers, let's take the problem x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5, and let's divide that all by 1 plus 2i. Okay. Oh, I'm sorry. It would be x minus 1 plus 2i. Okay, so what we're going to do is we are going to set this up. So our coefficient, and I'm going to leave myself a little more room because it takes a little more room with imaginary, so -2, 4, 2, and -5. And I'm still going to divide that by 1 plus 2i, because if you think of this in parentheses, I should have put that in parentheses, I'm sorry. So it's 1 plus 2i. So just like before, I'm going to bring this guy down, and I have 1. Well, 1 times an imaginary number, that imaginary number is just going to give me 1 plus 2i. And remember, you can only add, when you're adding imaginary numbers, you can only add your real parts and your imaginary parts. So there is no imaginary part here. There's no I after this. So all I can do is add the -2 and the 1. So I get -1 plus 2i. So now I have to multiply. Well, I have to multiply this guy by this guy, right? So if you need to, off to the side, and I'm going to just do this down here. I'm going to do, sorry, 1 plus 2i times another -1 plus 2i. Okay, and when I FOIL that out, I get -1 plus 2i minus 2i plus 4i squared. Okay, and this is nice because the two middle terms go away. And if you remember, what is I squared? Well, I squared is -1, so this last term becomes -4. So now I get -1 minus 4, which is -5. So this is nice because when I multiply these two right here, this guy and this guy, my answer simply becomes -5. So I'm going to get rid of that. Okay. So now you can see when we add straight down, we're going to get -1. So when we go ahead and multiply again, this times this, I simply get, -1 minus 2i. And remember, we can only add our real parts and our imaginary parts. So 2 minus 1 is the only thing I can do. So I'm going to get 1 minus 2i now. And now off to the side again, hopefully you're recognizing that you're going to have to FOIL again. You're going to multiply all of this times all of this. So I'm going to do it off to the side again. So 1 plus 2i times 1 minus 2i. And when I FOIL it out, I'm going to get 1 minus 2i plus 2i minus 4i squared. Take a second if you're not recognizing where I'm getting all that from. So now hopefully you can see this is nice because these two middle terms cancel. This guy equals -1, so I end up getting 1 plus 4. You see where the plus 4 came from? So that equals 5. Okay? So let me go ahead and get rid of that. Just remember that's 5. Oops. Okay. So we're going to write that 5 right here. And when we add straight down, this is 0. So this is going to become... So this actually is a very significant point. If you end up with 0, so if you recall, remember when we write these in final form, this is our remainder, right? Whatever number you have last is your remainder. So if you think about when you learned division a long time ago, if something divides something evenly, meaning there's no remainder left. So say, for example, 8 can be divided by 2, right? So if I have 8 divided by 2, that goes in 4 times evenly, and there's nothing left over, right? But if I divide 8 divided by 3, well, 3 only goes into 8 2 times, and then we've got 2 as a remainder. So what this is going to mean for us is that this guy, excuse me, where is it? Where's my highlighter? This guy is going to end up being a 0, or sorry, this is going to end up being a 0 of my polynomial. So, and a 0, remember, that's an x-intercept. So, you know, imaginary numbers really aren't on the x-axis, so that's why we're calling them zeros and not only x-intercepts in this from now on, because we can have zeros that do cross the x-axis, but we can also have zeros that don't cross the x-axis because they're imaginary. So what we say is that 1 plus 2i is a 0. And the word 0 comes actually from the fact that you have a 0 remainder. When we looked at those other examples and we did not have a 0 as a remainder, that would mean that that factor, or that divisor, is not a 0, or it's not an x-intercept. Okay, and that's about it. So now what I'd like to, because synthetic division is so critical to this chapter, what I'd like you to do is I would like you to try 2 examples. So I'm going to give you 2 examples, and then you have to promise me you're going to stop the video, try to work them out, and then I will put up the answers to this on the video, okay? So what I want you to do is I want you to try to divide 5x cubed minus 6x squared minus 28x minus 2, all divided by x plus 2. And I also want you to try x cubed minus 4x squared plus 9x minus 6, all divided by x minus 1. So please stop, try to write those out, stop the video, and then check your answer, okay? Okay, so hopefully this is what you got. So hopefully these are the answers that you got right here. That's the first one. Excuse me, and here is the second answer. So let's talk about interpreting these results, and this is the last thing, excuse me, for this video that I want to talk about. So you know that if you were to write this in answer form, you would say, you know, if you divide this big polynomial by x plus 2, your answer would be 5x squared minus 16x plus 4 with a remainder of 10. But more significantly, what it means is that the point, and I'm going to circle these really big here for you, negative 2 comma negative 10 is a point on that polynomial. So on our original polynomial, this guy right here, it contains the point, excuse me, let me write this really big. It contains the point negative 2, negative 10. So that point resides on that original polynomial. Down here at the second example, we have the point 1 comma 0. And remember, I told you this is significant because this guy, where does that point lie? Well, 1 comma 0 happens to lie on the x-axis. And as you know, whenever we're graphing lines or polynomials or anything that lies on the x-axis becomes a significant point. Those are x-intercepts, or solutions, or zeros, and so we're going to spend a lot of time in this chapter discovering all the zeros of a polynomial. So if you do your synthetic division, and your remainder comes out to be 0, then the number that you were dividing by happens to be a 0, we call it a 0, of that polynomial. Okay? So I hope that all makes sense. Good luck.